Okay, so I'm going to go back over the notes we did on Friday. I'm going to finish them, and then then we will do practice tomorrow in class. But rate of change and starting point, these are for graphs that don't have a line that starts at the origin. So we remember doing y equals kx. That was for a proportional graph, where k was the constant of proportionality. Well, now we are going to do this for graphs that don't start at the origin. So, two really important definitions are the rate of change and the starting point. Our starting point is where x equals 0. And that will be, we can use the b as our variable. Then we have rate of change, which is our change in y over our change in x. And that, as a fraction, reduced is your rate of change. So what we want to do is we want to say, what's the change in y values? And what is our change in x values? Okay, so from 5 to 9, I added 4. From 9 to 13, I added 4. From 13 to 17, I added 4. And from 17 to 21, I added 4. Okay, so my change in y is equal to 4. Now I have to go find my change in x. From 0 to 2, I added 2. From 2 to 4, I added 2. From 4 to 6, I added 2. And from 6 to 8, I added 2. So my change in x value is 2. And 4 over 2 reduced is just 2. That's my rate of change. My starting point, where x is 0, y is a number. Well, where x is 0, y is 5. So my starting point, b, equals 5. Or you can write it as an ordered pair of 0, 5. So what that's saying is if I were to graph it, my graph would start or intersect the y-axis at 0, 5. Okay, number 2. Calculate the rate of change in starting point. Well, in this graph, we aren't given the starting point like we were in the problem 1. So first, let's find our rate of change. Remember, that's our change in y over our change in x. So, okay, so from 11 to 20, I added 9. From 20 to 29, I added 9. From 29 to 38, I added 9. And from 38 to 47, I added 9. Well, what happened with my change in x is that I added 3 between each number. So, my change in y is 9. My change in x is 3, and that reduced is 3. So that is my rate of change. Now, I want to figure out what happens when x is 0. So if I was adding 3 to make my numbers bigger, I would subtract 3 to find my x value of 0. So I would continue to use my constant rate of change for x, and I would do it as many times as it would take to get my x value back to 0. In this case, it only took one time. For y, my y value changed by 9 every time I increased in my table. So if I want to work backwards, I'm going to subtract 9, and I will get 2. So my starting point is 0, 2, or we can say b equals 2, either way. Okay, now let's look really quickly at a graph. Well, the first step when you're given a graph is that we want to make a table to make it visually easier to see. So I'm going to go ahead and make x on the top always, and I'm going to pick some points. So I'm going to pick 0, 1, 1, 2, 3, 4, and I can actually do 2 and 3 as well. That's good enough for now. Alright, so my change in y values is every time I increase by 1, and every time for my x I increase by 1. So my rate of change, or ROC, is 1 over 1, which divides to be 1. My starting point is given to me. So this is my starting point, or you can see it in the table here. So 0, 1, or you can say b equals 1 when x is 0. Last one, my starting point can be clearly seen here at 0, 30, or b equals 30. That's where my graph intersects the y-axis, and that's important to remember as a rule. I'm also going to only use the points that they give me. So I have my x on top and y. So at 0, 30 is 1 point. At 224 is another. And at 612. And we can do one more at 10, 0. So every time I went down by 6, and that's really important to recognize if you're going up or down. So I'm going to use a negative to show that I'm going down each time. And then I'm going to go up by 2 each time here. And so this is a process. I'm going to go up by 2 on the first one. Slow down a little bit. Up by 4 on the second one. And up by 4 again. And the reason I jumped there, and I think I went a little fast down here, so I subtract by 6. This goes down by 12 if I correct myself. And so does this one. And if you can think to yourself, well, why do they jump? That's because I don't go up by 2 every time. I went up by 2, then I went up by 4, and by 4, so I have to be really careful of that. But the process is still the same. Change in y over change in x. My change in y for the first one is negative 6 over 2, and that reduces to negative 3. Now let's check to make sure that's the case for my other values. I have a negative 12 divided by 4, and that equals a negative 3. So what is my rate of change? You should have said it's negative 3. Okay, so this is the notes that we started on Friday and ended today on Monday.